Welcome to ePathshala lecture series in computer science, and this is a course in cloud computing. In this module, we are going to talk about cloud security. So, today's learning objectives would be we will look at we will see what do we mean by security in cloud, and then we will look at the critical aspects and the requirements for security in cloud, and we will look at the issues in each and every aspect of cloud, followed by summary. Now, security is the prevention or protection against any malicious attack. That could be an access to malicious access to the resources by unauthorized person. It could be intentional or unintentional destruction or alteration of information. It could be any vulnerabilities, protection of any vulnerabilities in the system. Cloud security has a similar connotation as normal IT security, but there are certain features in cloud which makes cloud security special. We need to provide special attention. So, during the preparation of cloud, there may have been certain technologies and mechanisms included in cloud which makes the security little bit different than what normal traditional security would go. So, different aspects in cloud may require special attention and it distinguishes cloud security from the traditional IT security, and that is why we have been seeing that security concern in cloud have been such a big issue in cloud adoption. So, what is cloud security exactly? It will be a set of procedures or tools whatever we develop for protection of services, which will be SaaS, PaaS, IaaS and or any other service, protection of our resources, which will be the compute resources, the network resources and the software resources, and in terms of the both the stakeholders as in the service providers and as well as the consumers. So, let us look at from the perspective of the stakeholders how cloud security works in terms of the three typical services that we look at. In SaaS, the major responsibility is obviously the providers, because they will be installing the software applications and they will be allowing users to clients to access. So, consumers responsibility will be to take as much security as possible and pay whatever is required for that. In IaaS offering, on the other hand, it is the other extreme where the underlying infrastructure will be the provider's responsibility, but the rest of the stack will be the consumer's responsibility in IaaS. A PaaS is in the middle between these two, where the platform will be the provider's perspective for securing the platform, and the development mechanisms will be the consumer's perspective. So, let us look at the different perspectives from which cloud security needs to be looked at. We need to look at the reasons for security problem, what makes it special than the normal IT infrastructure. We have to look at the critical aspects of cloud security. We will look at the requirements and the security issues, and of course, the standards, what is being done for securing cloud. So, why specifically security problem apart from normal IT security is virtualization. Because of the virtualization platform, there will be an additional security risk. Multi-tenancy, because we let the same server being shared by multiple consumers, thereby we allow multiple tenants or multiple users residing together on the same server. So, virtualization and multi-tenancy are quite complementary to each other, and both of them create the special problem in cloud security. Then we have the loss of control of data. When I have data in my premise, what control I can have on the data. when the data goes to the service provider's premise, my control is lost as far as the enterprise data is concerned. Lack of trust. How do I trust a service provider? As a consumer, how do I trust the service provider is a big concern in cloud security, and cloud security increases the attack surface. So, the attack surface will be the typical vulnerabilities that we have, and because of these aspects, the attack surface is increased in case of cloud. Last but not the least is the difficulty in auditing and forensics. We have seen in our last module that monitoring is such a important aspect of overall cloud management, and how difficult monitoring is. For the same reason, the extension is that auditing is difficult, and therefore, all the understanding whether there is a breach or not is a difficult aspect. So, who are the attackers in cloud? We have the outside attackers, people who are not part of cloud, but they want a piece of data or piece of information. So, they generate typically a denial of service, or they probe from outside into the cloud and they try to take some important data or information, and also they will pretend to be worker inside or a stakeholder inside, and they will do it. Perhaps the more problematic attackers are the insiders. They have the access to various parts of cloud, they have different authorizations already. So, they may want to exhaust resources, thereby creating a denial of service attack, or they can probe, and their probes is more dangerous because they have already certain accesses to the data. So, what are the critical aspects of cloud security? NIST provides a list of critical aspects. Data breach, data that is stored in the service provider that gets shared to unnecessary unauthorized personnel. Data loss, you keep my data and you lose the data, I will not have a copy of the data. Any kind of traffic hijacking, either the account hijacking or the service traffic hijacking. The APIs, the application programming interfaces, and any other interface, any vulnerability in the interface will allow an attack to happen. Denial of service, any kind of denial of service, you generate lot of requests, you eat up all the resources, any denial of service will be a critical aspect. And again, last but not the least, the insiders are the due diligence. Have you completed my work properly? Have you moved my data properly? The monitoring, lack of monitoring and proper diligence mechanism is a problem. All the technologies are shared in cloud. That is the strength of cloud, and that is the weakness of cloud. Loss of governance, I do not have control over my data. So, obviously, that is a very critical aspect. Vendor lock-in is a problem, and that is typically it is a problem of management, but still it is a security problem because the data gets locked in by one provider and it does not let others to take. When we want to delete data, has the data been deleted properly is another problem. And in availability chain, what happens is a cloud provider may not be able to provide all the services required. So, what they will do is they will go to a third party and take some service from them or part of the service from them. What about a security breach in the third party? Who is responsible for the security breach in third party? Is the service provider responsible, or is that person responsible who probably is not bound to the consumer through an SLA? So, the availability chain of work or service provision becomes a serious critical aspect. So, what are the requirements? We need an appropriate identification and authentication. We need proper authorization. Even when you have been identified to be a valid customer, what kind of accesses do you have? confidentiality, data is confidential data. So, that kind of requirement, integrity of data, data should not be allowed to change. Non-repudiation, so there will not be any problem with respect to having a non-repudiation factor, and availability. Data should always be available. That is also a security aspect, because due to some security attack the data may not be available, and providers must provide that. So, now let us look at each security aspects and issues thereof. These are the lists that we are going to look at: data center security, virtualization and hypervisor security, identity and access management, data and storage security, perhaps a very important security aspect, cryptography, how to use cryptography in cloud, governance in cloud, compliance and legal issues, and last but not the least, the network security. So, in physical or data security, what we have is the data centers. So, data centers should be secured properly. The building, the infrastructure, the physical building and all the machines must be secured, because that becomes a single point of failure. Once that is attacked, whatever other means, IT related means we can take, it becomes useless. So, physical security is important. The ultimate goal is to protect the information. Next comes the virtualization or the hypervisor security. Hypervisor, if we understand, it creates one layer of indirection, but it controls the overall environment. Hypervisor or virtualization environment gives me the overall control on the, or gives the service provider the overall control. In case there is a vulnerability inside the hypervisor, the whole system becomes very vulnerable. So, what are the mechanisms? A VM escape, which means that VMs, a hypervisor provides an isolated VM. The whole idea is that the VMs will be isolated, but they will be running on the same hardware. Now, if a intruder finds a way of crossing the border of the VM isolation and entering into the border of the other VM, then all the data that is available in the other VM will be accessible to the intruder VM. VM sprawl, I generate so many VMs in the environment that I create a denial of service. I unnecessarily create more and more virtual machines, and thereby I occupy resources, a resource that a legitimate client or consumer wants. Cross VM side channel attack, that is the attacking through the barrier of two virtual machines. Single point of failure, SPOF. The hypervisor becomes the single point of failure. If the hypervisor fails, then everything fails. So, an attack on the hypervisor actually makes the whole system useless. The network, not only inside the data center, even outside the data center, the network is virtualized. We have learned how we are virtualizing the network. What about that part of attacking? So, if we attack that, say we have a VPN and we attack the VPN, then the whole customer's access will be problem. And mobility, how do I clone my VMs, because nowadays cloning VM has become very popular, but the faster I develop my generate my VMs, the more resources I am actually eating up. The next issue is the identity and access management. This is not cloud specific. Access management is something that is available in a normal cloud, normal IT environment. Here, particularly in cloud, what we have concern is that data is given by the users to the cloud. Now, if we want to make the data available to the users, the identity management part must be reduced, must be lessened, so that quickly I can allow access to the users, thereby uplifting the concept of availability. It should be, data should be always available. So, if I take too much of time in identity management, then I am losing out on the users availability. So, how much I should do to ensure that the data is secured, but I can give quick access to the user. So, I have to do identity management, I have to do authentication of the user, I have to cross check that the authorization is as per the access control list that I may have kept, and also I have to give them a single sign on kind of environment. If the same user is accessing multiple aspects of cloud or multiple VMs or multiple resources, there should be a single sign on, and we should be able to give access. All these it's possible to give a very stringent measure regarding these, but the more stringent we become, the more delay we give to a authorized customer. So, there has to be a compromise between these two. Now, data is perhaps the most important reason why cloud security has been such a big dilemma in cloud. There are multiple aspects that we need to look at. Confidentiality of data. A data saved with a service provider is confidential and safe from others. Integrity of data. The data should not change without proper permission. Availability of data. Don't spend too much of time doing the security checks that I stay away from my data for a long time. Isolation of data. Keep my data away from others so that others cannot access. Data sharing only with my permission. My data will be shared with my permission. Backup and redundancy. How much backup are you allowed to do? How much redundancy you are creating is also a critical aspect in data. On the other hand, data sanitization. Sanitization refers to the fact that when I expunge my data, when I delete my data from a data storage, has the provider successfully deleted the data? That is sanitization. Data provenance, how the data is created, who has created it, using what chain of access the data has been cultivated. All these are part of data provenance. Dynamic data updates. As I change my data, are you able to keep track of whatever I am changing? Unreliable computing, don't allow my data to be accessed by others unnecessarily. Cryptography, we will talk about cryptography separately to look at the specific concern of cryptographic measures in cloud. So, on the other hand, storage has the confidentiality, integrity and the availability aspects, not data, but from the storage perspective. So, all these must be given by the cloud service provider and must be obtained through the service level agreement by the user. So, cryptography can be put in two ways. Very important in a cloud is that content aware encryption and format preserving encryption. When I give an address, that address should be retained in such a way, encrypted, but should be retained in such a way that the other users who are looking at the data even before decrypting should be able to understand that this is a address or this is a credit card number, but the number should be fudged so that I do not see the number, but I know that this is a credit card number. So, format preserving encryption is becoming very popular now. Now, the point is that when I encrypt my data, whatever form I encrypt with, but when I encrypt my data and store in the cloud, what happens if I need to search the data? What happens when I need to act on my data, change my data? I run batch processing kind of mechanisms and I use that data to compute something else. If I encrypt it, I have to pass on my key to the service providers and I have to trust the service providers. There are many mechanisms which are now in place or coming into place. One such mechanism is called a searchable encryption, where the data is encrypted in such a way that there will be keywords still retained in the data, and search can be made for blocks or for chunks of data using those keywords. That is called a searchable encryption. The other which allows implementation of some calculations on an encrypted data is a special form of encryption called homomorphic encryption. All these are upcoming mechanisms, none of them have really matured to become a proper mechanism, but the whole of the research world is trying to find out in collaboration with the industry for this. Governance of data is the control of data by the users. So, we can either do a overall management and decide, or specifically we can decide data should be expunged properly and monitored, data should not be leaked. All these are part of governance, including the vendor lock-in. How long should I keep the data with you? Can I take it out and give it to someone else? Can I take a chunk of the data out to compute on it in another cloud? All these are vendor lock-in issues and governance issues. Compliance that compliance means conforming to a stated requirement, and which location. So, many European countries have a restriction that the data should not leave certain regions. So, is my service provider conforming to that? So, data location, where my service provider is storing the data, contracts and electronic discovery. How about my contracts and the e-discovery process? How my other laws and regulations, all these are being abided by the cloud service provider. Auditing is the mechanism of looking into the data and the services and making sure that the data conforms to the services conform to whatever we have agreed upon. So, this assessment has to be done, typically is done by a third party. We have third party auditors who do this. The providers have to agree to such auditing mechanism. So, the provider has to make the system auditable, so that either the user or a third party auditor can go and audit it. So, this is the health of the system, the health status of the system that has to be checked and monitored using the auditing. We come to the network security issues, and here we will talk about a few attacks that happens. This is a list of security issues associated with network and overall cloud environment. XML signature wrapping attack, and a signature in XML data, a signature is used for authentication and integrity in a SOAP message. So, a part of the message is a signature is added as part of the message. So, that will be the part, and this specific part can be used by the attacker to generate, to include some malicious code. This is the XML signature wrapping attack. It is a common attack not only in cloud, in normal environment as well. Flooding attack, where a large number of virtual machines and requests are flooded with, the system is flooded with a large number of requests and virtual machines, thereby the server has to check whether this request is fake or this request is a proper legitimate request, and what happens is normal proper legitimate request will be starving. This is a typical denial of service attack. Malware injection attack, where the attacker creates a service and deploys the service. You take a pass, you generate a service, but the malicious code that you put inside the service will actually harm a request. But if the cloud service provider is not able to understand that, then a valid request will be put into the service and the requester's data will be misused by the service attacker. SQL injection, where a code will be injected, a malicious code will be injected through an SQL query, and therefore, the database is in trouble. A cross-site scripting attack, in which a wrong code will be uploaded in the web content, and therefore, the website will be forced to do malicious actions, take malicious actions on the on whoever is requesting it. Insecure API metadata. APIs are the interfaces, we already talked about it, that they are the door to a service, interfaces are the door to a service. So, security and availability of a cloud service may be compromised through a wrong interface. If the interface is not very robustly designed, then attacker may attack through the interface itself. And spoofing attack, in which we have that the there are a set of metadata files which will be used by the by a website authorization mechanism. So, if for example, a WSDL file, if a malicious code is included in such files, then the client machine which will download this to avail of a service, they will download such metadata file, and the file themselves will contain some wrong information which will attack the basic system of the client machine. So, these are the various attacks that we looked at. Now, a security can be offered as a service. What we mean by security offered as a service? Cloud service provider or an enterprise having the security mechanisms may offer through the cloud to be used specific security by an enterprise. So, if an enterprise requires a specific security mechanism, say it could be an antivirus, it could be a firewall, it could be a intrusion detection system, instead of developing their own such mechanisms, they can simply hire these services from the users, from the service providers, and this will be used as a service. This is called a security as a service. So, these are the various standards that are available in the environment today, and standards are important aspect of cloud security. So, SAS 70, ISO 27001, Safe Harbor. Of these, SAS 70 perhaps is the very popular and most used security standard. NIST has a security standard, HIPAA, FISMA, COPIT, these are all security standard. To summarize today's module, we looked at what is a cloud security, and we understood why security is a specific aspect of worry to the users. Although cloud security now has become less of a problem because of so many ways of countering the problem of cloud security, we looked at critical aspects of cloud security. We looked at the various threats that happens, including the security requirements, and we looked at the security issues, and of course followed by standard. These are our references. Thank you.